3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at the engine that helped propel SpaceX to success. Currently, SpaceX is hard at work on Starship variants, Raptor engine production, and much more with the future goal of the Moon, Mars, and beyond. However, important launch vehicles including the Falcon 9 and Falcon Heavy continue to launch using the Merlin engine. While not nearly as powerful as Raptor, it still showcases very impressive and revolutionary rocket engine technology and performance. Over time, SpaceX developed and manufactured the Merlin engine for launch vehicles including the Falcon 1, Falcon 9, and Falcon Heavy. The Merlin engine is unique because of its variance in use, success over time, and overall performance, all of which combine into a single engine that was arguably a big reason for SpaceX's early and continued success. Even today, with Falcon 9 launches still happening at a very consistent pace. A rocket engine is an extremely complicated piece of technology and engineering. A lot of factors are considered when designing an engine, which plays a big role in its success and reliability. Each engine turns propellant into thrust in a very violent and necessary process to lift a rocket off the ground. In SpaceX's case, it also helps deliver payloads, land rockets, and even more. Merlin Background. The Merlin engine has an extensive family and many past models, starting with the Merlin 1A. This engine was used for the Falcon 1 first stage, and flew multiple times including in 2006, when it caught fire and failed due to a fuel leak shortly after launch. It wasn't perfect, but the Merlin 1A was an impressive first step, and produced 76,000 pounds of thrust. From here, SpaceX continued to make changes and upgrades through different models, including the Merlin 1B, 1C, and 1D. All of which included various improvements such as power, efficiency, reliability, cost, and more. The Merlin 1D engine was developed by SpaceX between 2011 and 2012, with the first flight in 2013. In the same year, Musk stated that the engine was actually operating at 85% of its potential, and they anticipated to be able to increase the sea-level thrust to about 165,000 pounds of force. From here, SpaceX continued to work on and upgrade the Merlin 1D, pushing the engine to its limits. Production of the engine also changed a lot over time. In 2011, SpaceX was producing Merlin engines at the rate of 8 per month, planning to eventually raise production to about 33 engines per month. Only a few years later, in 2013, SpaceX's manufacturing space increased significantly, meaning the company was able to produce enough rocket cores to use all those engines. The company continued to produce and install engines on the Falcon 9, helping facilitate very consistent launches and more. Merlin Features. Variance and use. The first important aspect of the Merlin engine I want to highlight is the variance and use. As I mentioned prior, the engine has a long history of different versions. However, I am going to focus on the current Merlin 1D. Here you have a sea-level and a vacuum Merlin. The Merlin engines use rocket-grade kerosene or RP1 and liquid oxygen as rocket propellants in a gas generator power cycle. The Merlin engine was originally designed for recovery and reuse. The sea-level Merlin engine produces 845 kN or 190,000 pounds of force. This is a significant step up from some of the initial Merlin models, which produce less than 80,000 pounds of force. Currently, this same sea-level Merlin is used on SpaceX's Falcon 9 and Falcon Heavy. Specifically, there are 9 on the first stage of the Falcon 9, and 27 in total on the boosters of the Falcon Heavy. The Merlin vacuum is similar in many ways, but features a few important differences. The vacuum variant features a larger exhaust section and a significantly larger expansion nozzle to maximize the engine's efficiency in the vacuum of space. Its combustion chamber is regeneratively cooled, while the expansion nozzle is radiatively cooled. At full power, the Merlin vacuum engine operates with the greatest efficiency ever for an American-made hydrocarbon rocket engine. This engine produces a thrust of 981 kN or 220,500 pounds of force in the vacuum of space. Success over time. Another important feature of the Merlin engine has been its consistency and continued success over time. So far, the Falcon 9 has managed to complete 134 total launches, 94 total landings, and 75 reflown rockets, all of which were powered by Merlin engines on the first and second stage. As for the Falcon Heavy, it has had 3 total launches, 7 total landings, and 4 reflown rockets. In the Falcon 9's case, the 9 Merlin engines on the first stage are gradually throttled near the end of first stage flight to limit launch vehicle acceleration as the rocket's mass decreases with the burning of fuel. These engines are also used to reorient the first stage prior to re-entry, and to decelerate the vehicle for landing. As for the Falcon Heavy, the first stage incorporates 27 Merlin engines across the 3 aluminum lithium alloy rocket cores containing liquid oxygen and rocket-grade kerosene propellant. These 27 Merlin engines managed to produce more than 5 million pounds of thrust at liftoff. Throughout all these launches, there have been very few errors or failures. In March of 2020, a Falcon 9 experienced an early engine shutdown when launching Starlink satellites. The rest of the engines continued to burn and managed to deliver the payload to orbit. However, the first stage was not successfully recovered. SpaceX did an investigation and found that isopropyl alcohol, used as cleaning fluid, was trapped and ignited, causing the engine to be shut down. In October of the same year, a launch was aborted seconds before liftoff due to a detected early startup on 2 of the 9 engines on the first stage. After removing and testing the engines, it was found that a port in the gas generator cycle was blocked. Once fixed, the engines worked as intended. With the expectation of these few anomalies, the Merlin engine is extremely reliable and well tested. Overall performance. The final feature of the Merlin engine I want to mention has to do with the overall and more in-depth performance of the engine. The Merlin has the highest thrust-to-weight ratio of any boost engine ever made. The engine features a reliable turbopump design with a single shaft for the liquid oxygen pump, the fuel pump, and the turbine. The engine uses a gas generator cycle instead of the more complex stage combustion cycle. The regeneratively cooled nozzle and thrust chamber use a milled copper alloy liner that provides large heat flux margins. In addition, a Pintley injector provides inherent combustion stability. Due to the high volume production of Merlin engines for every launch, it results in high product quality and repeatability through process control and continuous production. Flying several engines on each mission also quickly builds substantial engineering data and flight heritage. Conclusion. Over time, the Merlin engine has proved to be not only extremely reliable but also efficient, cost-effective, and much more. Almost 2 decades ago, SpaceX began developing and working on the initial Merlin engines. Over the years, it continued to grow and change based on new needs and goals for the future. In addition, SpaceX was able to upgrade it to one of the most powerful engines in its class. This is thanks to the Merlin's unique variance and use, success over time, and overall performance, all of which play a key role in the Merlin's power and use on different rockets such as the Falcon 9 and Heavy. We will have to hope for the continued success of Merlin and see the impact it has on the future of the space industry and more. Thank you very much for watching.